Let us see in this class an introduction about sprinkler irrigation. What is sprinkler irrigation? Sprinkler irrigation is like artificial rainfall that is used for irrigation of crops. The pressure requirement for operation of sprinkler irrigation system varies between 15 meters to 40 meters. Nowadays, even more than 40-meter pressure is also needed to operate very large sprinklers like rain guns. It should be kept in mind that this pressure is needed for operation of sprinkler irrigation systems alone. If water level in the well is, say, 100 meters below the ground, then your pump should be able to develop pressure for lifting the water from lower elevation to 100 meters, and over and above that you should have a pressure of 15 meters to 40 meters. That means your pressure, your pump should be able to develop 115 meters to 140 meters of pressure. Sprinkler irrigation can be used for all the crops because sprinkler irrigation after all gives only water to the crops. So all crops need water. So all crops can be irrigated by sprinkler irrigation. Let us see what are the advantages of using sprinkler irrigation system. Sprinkler irrigation system is well adopted in rolling topography wherein shallow soil exists. In rolling topography, we cannot do leveling work at all. If we do leveling, then the shallow soil has to be removed and there will be rock outcrops in many locations. So in such a kind of topography, if we make use of sprinkler irrigation, then it becomes easy and we can irrigate the crops without causing any runoff in rolling topography. Sprinkler irrigation can be very well used when we want to modify weather extremes. In tropical countries like India, in summer and all, we get a very high temperature. For instance, when we grow groundnut crops, that too in summer, even if we apply water, the groundnut crop will not be able to take water because of the extreme heatness. We can also see in our real life that during summer, we will not be able to eat very well. At the same time, when we get into the air-conditioned room during summer, we'll become very comfortable and our metabolic activities will become normal. So, same is the case for the crops also. So, when we have a very hot summer, during that times, if we irrigate with sprinkler irrigation, then we will increase the humidity around the crops and we will be able to cool the crop. And that is, we create a congenial microclimate for the crop. So that kind of modification of weather extremes is possible with sprinkler irrigation. In very cold areas, during morning and all, one will find on the leaves ice crystals get formed. This is called frost, and this kind of a frost can be removed by operation of the sprinklers. And when you operate the sprinklers, the ice crystals will get removed from the foliage. Sprinkler irrigation can also be used to spray pesticides. it becomes very easy to spray pesticides. One does not need a sprayer as a separate equipment. Similarly, urea can be sprayed on foliage. When you apply nitrogen, when we apply urea to the crops through soil, then there is a possibility of more of loss. So instead, if you apply urea through sprinklers, then the nitrogen uptake will be much better. And one more advantage with the sprinkler is we need to spend only less on the labor. And last and the important advantage is that with the sprinklers, we will be able to apply water very efficiently, and we will be able to get an application efficiency of 80% and above. Let us see now the disadvantages of using sprinkler irrigation. As with any technology, this is also a high investment cost method. So fixed cost for sprinkler irrigation is more, and the operating cost for pressurizing water is also added. And the third disadvantage is the foliage gets wetted every time we irrigate. When we go in under the rain and all, we get cold. Similarly, crops also, if they are wetted too much often, then they get a disease. So this is one disadvantage. And one more disadvantage is that every time when we are applying water on the foliage, the salt in the water will get deposited over the leaves, and that salt will cause leaf burning. So it's another disadvantage. The disadvantages get multiplied when we make use of saline water for sprinkler irrigation. Let us say if the sodium content is greater than 70 ppm in the water and the chloride content is greater than 105 ppm in the water, and when water is applied, this kind of water on the leaves, and these salts are absorbed by leaves of some crops and their metabolic activities get affected. If the water contains high concentrations of bicarbonates, and when we use that kind of water to sprinkle on the crops, it affects the quality of the fruits. Even with very good quality of water, if we use sprinkler irrigation, there is a possibility that for citrus and grapes, the fruit quality gets very much affected. In soils with very less infiltration, like clay soils which have infiltration rate less than 3 millimeter per hour, if we make use of sprinkler irrigation, there is a possibility of runoff. If runoff occurs, there is a possibility that the uniformity of application gets very much affected. In windy areas, it's very difficult to operate the sprinkler irrigation. Especially in irregular shaped fields, spacing of sprinklers becomes very inconvenient, and most of the time we will be sprinkling our water to the neighbors' fields and will cause issues. So these are all some of the disadvantages of making use of sprinkler irrigation. Let us see the types of sprinkler irrigation. There are 4 types of sprinkler irrigation system. One is set system, and another is continuous move system, and third is periodic move system, and fourth is a linear move sprinklers. And what is set system? In a set system, all pipes and sprinklers will be fixed and it cannot be moved. And it's a very costly system and it is very rarely used. Next is continuous move system. In this system, the entire sprinkler system along with the pipes moves slowly while irrigating. And these kinds of systems are not normally used in India. They are used mostly in West and also in America. And the third system is periodic move system. And this is the system which is being used very much in India. In this system, the pipes and the sprinklers are movable. The total area is divided into the total area that has to be irrigated is divided into small units. At a time, only one unit is irrigated. After one unit is irrigated, then the pipes and sprinklers are moved to the nearby unit and irrigation is done. This is a less cost system than set system. The periodic move system and set system will appear one and the same as far as irrigation is concerned. But only thing is that set system, in the set system, we cannot move the pipes and sprinklers, and in periodic move system, we will be able to move the pipes and sprinklers from one place to the other after irrigating one unit at a time. Periodic move system is comparatively of less cost and the labor requirement for movement is also very less. And this is the continuous move system. This is an image which depicts a continuous move system. And this is called the boom type. In boom type, at both the ends, the sprinkler system is kept on the wheels. When irrigation is being done, the entire system will linearly move. The system will linearly move this way, and water is supplied through a hose. You see here. So this is a hydrant from which water is supplied to this system, and it moves linearly. Sometimes this, instead of this place, we can also have here a long canals. Along the canals, the suction pipe will be placed inside and water will be supplied to this system continuously. And the next is center pivot system. See this, it's a very huge system. The lengths of these systems, the lengths of these sprinklers, they range from 100 meters to few kilometers. And in center pivot system, the center is fixed and the end is movable and it is kept on the wheels and it slowly moves this way and sprinkling is done. And these kind of large kind of systems, as I already told, these systems are very much used only in Europe and West, and they are not used in India. And next is fourth system is a linear move system, and this kind of systems are in many places they are used in India also. It has a one large sprinkler and it is kept on the wheels and the water is supplied through a flexible hose, and when sprinkling is done, the cable is dragged behind and it moves very slowly. The the energy for dragging the sprinkler is obtained from the energy of the pressurized water itself. And it has a disadvantage that we have to allow a path. We have to allow a path for movement of this sprinkler. So this is a wastage of cultivable area. Now we will see in detail about periodic move system. In our syllabus, we will be concentrating fully on only periodic move system and design. All other systems are not very much used in India, and hence they are also not in syllabus. Now we will start seeing periodic move sprinklers fittings. As I already told you, periodic move sprinkler systems have the ability to be moved from one place to the other. So the fittings are made in such a way that they can be fitted very easily or without any difficulty. It will not have much of threaded fittings. You see, this is a pipe in which we have, this is called bell mouth end, and on this side you have a facility for attaching a hook, and this is called rear end. We have a hook, and this can be tilted. See here how when two pipes are connected together, how it appears. And this pipe will have a washer at this end. And this washer has the ability to expand, and when pressure is increased to its sufficient level, say 25 meters to 40 meters, then leakage would get arrested. When sprinkler pipes are operated with less pressure than the optimal pressure, you will find that sprinkler pipes are in leak. So when they are operated with the optimal pressure, you will find that there will not be any leak at all. And these are all some of the fittings. Those are commonly used in periodic move system. Obviously, this is a bend. When we need to bend your supply pipe, then we can make use of this. And this is a T. So when we want to divide a supply pipe into two lines, wherein you want to, on one side you want to use some sprinklers, on other side also you want to use some sprinklers, then you can make use of T. And this is a end block. So at the end, when you want to close it, then you can use it. You can use this block. So let us assume that you want to close this end, which is open. Then you can make use of this end block here. And lastly, and more importantly, this is called a saddle. This is another fitting that can be removed. A saddle has a facility of connecting a riser pipe, and the riser pipe will be connected with thread, and at the other end of the riser pipe there will be another thread in which the sprinklers will be fitted. So this is a one full setup. A saddle, a riser pipe, and a sprinkler can be put together and can be taken out, and it can be fitted at any place after we irrigate one place. We will see the components those are needed in sprinkler irrigation system. The first and foremost component which is needed in sprinkler irrigation system is pump. Why is pump needed? Pump is needed to force water to come out of sprinkler as a jet. All pumps can be used for sprinkler irrigation system, which is able to develop the pressure needed for sprinkler irrigation system, except compressor pump. As you know, the compressor pump makes use of air for lifting the water. So that compressor pump does not give water in a continuous way. So compressor pump cannot be used for using sprinkler irrigation system. Our pump should be able to develop pressure between 20 meters to 40 meters over and above lifting the water from bottom of the well to the bank. So that should be kept in mind. This table gives you an idea about the diameters of the pipes and the pressure ratings with which the pipes are available in the market. See here, the pipe diameter varies from 32 meters to 120, 32 millimeters to 125 millimeters. And the pressure ratings, those are available in the market, varies from 2.5 kilogram per square centimeter to 8 kilogram per square centimeter. So depending on the pressure with which we operate our sprinklers, we should select the sprinkler pipes. Obviously, the less pressure rating pipes, say 2.5 kSc pressure pipes, will have a lower cost than 4 kSc, then 6 kSc, and then 8 kSc. 8 kSc will have the highest cost. Let us see types of nozzle. Nozzle, there are two types of nozzle. One is a single nozzle and another is a double nozzle. See here, this is a single nozzle type. It has only one nozzle and it has an important part called rocker arm. This is called rocker arm, and you have a restoring spring. So when water is issued out of this nozzle, it hits on the rocker arm and it is tiltable and it tilts and hits on the sprinkler and which causes the rotation of the sprinkler. And once it gives one impact and it is restored by this restoring spring. So by this way, the sprinkler operates continuously and it keeps rotating. This kind of a single nozzle sprinklers are used for smaller diameters as well as for very high or high diameters, diameter of throws. This is a double nozzle sprinkler. You see here you have a one nozzle here and another nozzle here. This is a smaller nozzle and this is a larger nozzle. This smaller nozzle will cover inner areas of the circle and this larger nozzle will cover peripheral areas of the wetted circle. And these kinds of sprinklers are used for medium to very high diameter of throws. And these sprinklers also rotate by impact. It also, see here, it also has a rocker arm. And this is called a special type of sprinkler called rain gun. Rain guns are all, they are not very much different. They are large sprinklers, that's all. And rain guns may be a single nozzle or it may be a double nozzle. See here, this has a two nozzle, a smaller nozzle and a larger nozzle. This also has a smaller nozzle and a larger nozzle. And these rain guns have a very high diameter of spray. And the pressure needed is most of the time is more than 30 meters. Nowadays, even 40 meter pressure to 60 meter pressure rain guns are available in the market. And in rain guns also there are two kinds of rotation of sprinklers possible. One is impact type, and it has a rocker arm which causes the rotation. And there is one more kind of a rotational facility for the sprinkler, for the rain guns, is that a, a small gear will be placed inside, and that gear will get energy from the incoming water, and that gear will cause the rotation. And these kind of sprinklers with gear will have a very smooth rotation than the impact type sprinklers. So this kind of gear type rotation comes only in rain guns. This is a table which talks about sprinkler characteristics of different sprinklers of different pressure. There are 1, 2, 3, 4, 5 ranges of pressure. One is low pressure. Low pressure varies between 3.5 meters to 14 meters of pressure head. And this class of sprinklers, most of the time they are impact type, and they have a special pressure spring, and most of the time they are single nozzle, and they get a diameter of 6 meters to 15 meters. And the minimum precipitation from those sprinklers is 10 millimeter per hour, and most of the time they have a large drop. And uniformity of sprinkler we obtain from low pressure sprinklers is fair. Next class is medium pressure. The medium pressure is 10.5 to 21 meter pressure head, and they are impact or gear type rotation. They make use of single or double nozzle, and their wetted diameter is 16 meters to 24 meters, and the minimum precipitation is 3 millimeter per hour, and their droplets are medium-sized droplets. Precipitation uniformity is very good for medium pressure sprinklers. The high pressure sprinklers have the pressure range of 21 meters to 69 meters, and the rotation is brought about by impact or gear type, and the wetted diameter is between 23 meters and 37 meters. The minimum precipitation we get is between 25 is around 2.5 millimeters per hour. The breaking of the jet causes medium droplets to come, and it has a very good uniformity. The fourth is very high pressure class, and for which we need pressure of 34 meters to 69 meters, and these sprinklers are also impact or gear type. Here also we have single or double nozzle. Wetted diameter varies from 34 meters to 90 meters, and the precipitation is larger. We get a larger precipitation of 10 millimeter per hour. We get medium droplets, and we get a precipitation uniformity very good. But if velocity of the wind is more, then uniformity gets very much affected, and if the velocity of the wind is more than 6.4 kilometers per hour, uniformity gets affected very much. And last is the giant models, and it has a pressure greater than 55 meters, and they have a rotation of sprinklers with the gears, and mostly they are double nozzled, and they weight a diameter of 61 meters to 122 meters. The precipitation is still larger. We get 15 millimeter per hour, and droplets are very small. So when we get a very small droplets, when there is wind, and there is possibility of drift will also be more. And these kinds of giant models are not very much used for agriculture. They are very much used in golf grounds, wherein very large areas are irrigated. Now let us see how the sprinkler heads can be selected, and what are all the factors that should be considered when we select sprinkler heads. When we make use of small sizes of sprinklers, we may have to use more number of nozzles. And when we use more number of nozzles, we need to have more pipes. So the cost of installing small size sprinklers with more pipes will be more. So the fixed cost of small size nozzles usage will be more. And when we use small size sprinklers, the operating cost will be less, because the pressure needed will be very less, because we are throwing the water to a smaller distance. So the electricity spent on sprinkling will be very less. And the problem due to wind also in small size sprinklers, it will be less, because the water is suspended in the atmosphere for a less time. So there will not be much drift problem. On the other hand, if we use bigger nozzle, then the number of nozzles used will be very less, and the pipes used will also be less, and the cost, total fixed cost, will become very less. But operating cost will become more, because we have to throw the water to a larger distance, so pressure needed is more and electricity needed is also more. And wind problem will also be more, because the water jet will be in suspension for a longer time and for a longer distance. So one has to decide on whether to go for small size sprinklers or for bigger size sprinklers, depending on one's preference. If one wants to invest lower cost, one can go for larger sprinklers, and uniformity will get decreased. So accordingly, one can select whether smaller sprinklers or bigger sprinklers. In clay soils and undulating topography, the precipitation rate should be considered. If the precipitation rate of the sprinklers is more, then it may cause runoff. So precipitation rate should not cause runoff. In such a way, the sprinkler heads should be selected. And this slide shows how the precipitation depth will be at different locations from the sprinkler. So this is a sprinkler location, and this is a jet. This is the jet, and this is horizontal, and this curve indicates the depth of water that is obtained at each location. This is the depth of water obtained at each location. So for this diagram is for twin nozzle sprinkler. When pressure is low, how the precipitation rate will be, how the precipitation depth will be. Nearer the sprinkler, you get a larger depth. Farther the sprinkler, you get the larger depth. In between, you get a lower depth. It is because when pressure is low, what will happen is the larger nozzle throw. The larger nozzle is supposed to cover this area also. So what will happen is the jet will come out and it will go as a jet without breaking. When it is not breaking into droplets, it will reach the periphery and it will not fall here. This is a image for correct operation of pressure. See here, it's a triangular pattern. This is the depth of water applied at each and every location radially from the sprinkler. At the near the sprinkler, you get maximum depth, and as you go to the periphery, it goes to 0. So this is the correct pressure. And third is when pressure is excess, how the precipitation profile will be. when pressure is excess, what will happen is when the jet comes out of the sprinkler, it will break down into very, very small droplets, and it will not have energy to travel. So what will happen is all the droplets will fall down near the sprinkler itself. One may think that when pressure is excess, one will get a larger depth of water at the periphery. It does not happen so. What happens is the droplets becomes very small and they lose the energy to travel, and all the droplets fall very near the sprinkler, and you get a precipitation profile, something like this. So this pressure excess is also not good, pressure low is also not good, pressure correct is good for operation. And when we are spacing sprinklers, there should be overlap. See here, this is a this is a this is a one sprinkler and it's another adjoining sprinkler. When the overlap is lower, how the water depth of water received looks like? Nearer more, at farther you get a less water. So if you keep on increasing the overlap, you find that the uniformity of depth of water applied gets improved. And here it is almost uniform. So this is the overlap one should aim for. And there are three kinds of spacings adopted in sprinkler heads. One is called rectangle. See here, this is a one sprinkler, this is another sprinkler head, and this is another sprinkler head. So how they are placed in rectangle on one side at a larger spacing, 60% or 0.6 of the wetted diameter, and on the other side 40% of the diameter. So another type is equal, 50% of the diameter on one side and on the other side also 50% of the diameter. So this is called square spacing. So compared to square and rectangle will have less cost than square, because let us assume that this is the direction of main pipe, and this is a lateral. In this case, our laterals are spaced at a larger distance than this. Let us say here we have a main pipe, and this is the direction of laterals. Then laterals are placed at a smaller distance in square, and it is at a larger distance in rectangle. So we will have the number of laterals to be lesser at rectangle. So if you have a control valve at every lateral, then the cost of the control valve gets reduced in rectangular spacing, and in case of square spacing, it gets increased. And the third is triangle. It appears, let us say this is the main pipe, and we have a lateral running this way. In one lateral we are spacing sprinklers like this, and in the adjoining lateral we space the sprinklers like this. And if you look at the spacing of sprinklers, it appears something like triangle, and this is the triangle, and the side of each triangle is 62% of the wetted diameter. And this kind of a triangular spacing has been found to give maximum uniformity, and it is very much recommended. When we decide on spacing between sprinklers for periodic mode system, we should keep in mind that it should be in multiples of 6 meters or 3 meters, because the pipes are available in the market only in 3 meters and 6 meters. So we cannot cut the pipe every time when we make use of the periodic mode system. So the spacing should be selected in such a way that it is either 3 meters or 6 meters or in multiples of 3 meters and 6 meters. During wind, the sprinkler spacing can be reduced in order to increase the uniformity. During wind, we should also operate the sprinklers near minimum optimal pressure. It should not be operated with the maximum operating pressure, because if you operate with the minimum pressure, when water comes out as a jet, then it will come out as a, a larger jet and it will have a larger droplets. Because of wind, the larger droplets will not get affected and it will not last due to wind as a drift. Next is riser pipe. Why is riser pipe used? It is used to raise the jet above the crop. So what can be the height of the riser pipe? It depends on height of the crop. Say for a groundnut, a smaller riser pipe is sufficient. Say for a sugar cane, we may have to have a riser pipe around even 1.5 meters to 2 meters. And in deciding the riser pipe, one more factor has to be considered. If the riser pipe has a lower height, what will happen is water from main pipe gets a turn and it passes through the riser pipe. And if it is very small, turbulence will be caused in the riser pipe and there will be breakage of the water in the riser pipe. Actually, the water should break into droplets only at the exit of the jet, not inside the riser pipe. So if it happens, there is a possibility that uniformity of application would get affected. So longer riser pipe minimizes turbulence. That should be kept in mind. This is a table which gives us minimum riser pipe heights which are recommended based on sprinkler discharge. It varies between less than 0.6 liter per second to greater than 7.6 liter per second. And for different ranges, the recommended minimum riser heights are given, and that has to be adopted. Next, we will see how sprinkler set can be evaluated after sprinkler is installed. When sprinkler is evaluated, at least 4 sprinklers should be operated simultaneously, or if it is not possible to operate 4 sprinklers simultaneously, one can operate one sprinkler after the other, but we should evaluate a rectangular area between 4 locations of the sprinkler. In this case, I have shown with 2 meters distance, one has to take different containers. They are called catch cans. They are like very small tumblers which has a volume of around 50 ml and they are placed like this, and sprinkler has to be operated for some time and water collected in each tank has to be measured with a measuring cylinder and they have to be noted. And from the variation of the water collected in these sprinklers, one will be able to find out with what uniformity water is applied through this sprinkler setup. And this is the formula used for finding the uniformity of sprinkling. This is called Christiansen's uniformity coefficient formula. This is 100 into 1 minus mod of z minus m divided by nm, and it is summed over all the tumblers. I equal to 1 to n indicates the first tumbler to nth tumbler, and z is the depth of water collected in each can. The m is the mean of the water collected in all the cans, and N is the total number of the cans. So if you apply this formula, one will be able to find out what is the uniformity with which water is applied to the crops in the installed system. If we get a uniformity coefficient of 80% and above, it is very good. If it is less than that, then it's not good and it's not advisable. And when we are irrigating with a sprinkler irrigation system, we need to limit the depth of water applied in each time of irrigation. So for which the knowledge on field capacities of soils is important. For different soils, field capacities are given. For very coarse sand, the range is uh, between 33 mm to 62 mm per meter depth of soil. On average, it is 42. Like that, for all the crops, for all the soils, the range of field capacities are given. So when we irrigate, we should not apply water more than this depth. For instance, in very coarse sand, if we want to irrigate 1 meter depth of soil, we should not apply beyond 42 mm. If we apply beyond 42 mm, the water will go below 1 meter and it may get wasted. So one should decide on what is the depth of root zone, and accordingly to wet that depth of root zone, one has to decide on how much depth of water should be applied, and in that way water should be applied. So application rate can be found out using this simple formula. What is the depth of water applied per unit time? This is a data which is useful practically in moderately wet soils. The depth of soil wetted will be 20 times the water applied. Let us say if you are applying 5 centimeters of water in a moderately wet soil, 100 centimeters of soil will get wetted. Similarly, in case of dry soils, 10 times of the depth of water applied will get wetted. The very good way of wetting, a very good way of deciding time of operation in sprinkler irrigation is to see the root depth and irrigate accordingly. We should not operate the sprinkler irrigation so that water does not go beyond root zone. It's a good way of irrigation with the sprinklers, and for which the best way is to cut open the soil and examine the root depth at every stage of the crop. If it is done, the wastage of water during irrigation can be very much minimized. So with that, we conclude the first class of sprinkler irrigation introduction.